the focus of the rest of our chapter. So, first, we could start with a reaction description. So this is going to use like the full words. So when we start with the reaction description, it's the full words. So here, like say we have hydrogen gas reacts with oxygen. Oops, I spelled oxygen wrong. Oxygen gas to produce liquid water. So what you want to do is you want to interpret what are the reactants, draw an arrow, and then tell me what the products are. So here's a reactant. It reacts with another reactant to make, so that's where we'd have the arrow, and here is a product. So hydrogen gas. So what is hydrogen when it's all by itself? Needs to be H2. So you go H2 and put a G there to say that it's gas. Then you put a plus sign to say that it's reacting with something else. It's reacting with oxygen gas. What is oxygen? Go ahead. O2, yes. And we put a gas, a G for gas. So now I want you to be putting states for all of these when we do this. Then you put an arrow to show what it produces. Then you read, okay, what is the product? It is liquid water. So H2O. And it's not aqueous because at room temperature, water is liquid. Only when things are dissolved in water is it aqueous. Oh crap, I put it in the wrong space. The word equation should have been hydrogen plus oxygen equals water, but whatever. That's just boring. Okay, so let's just keep going. Is that okay?
Can we just draw an arrow down the scale?
I don't want to do, sure, yeah. Okay, so then how do we balance this? Well, I'm going to show you the main way to do this that will apply to the whole rest of the chapter. What I do is I draw a line down the arrow. Okay? Now, you need to make sure that you have the same number of atoms of one thing on both sides. So what I do is I write out what I have available. So on this side, I have H's and I have O's. And on this side, I have H's and I have O's. Now, sometimes, well, no, I'll show that to you later. Okay, so if you count how many atoms are on this side of, for hydrogen, how many atoms do we have? 2. How many atoms of oxygen? 2. Okay, now on this side, how many atoms of hydrogen do I have? 2. How many atoms of oxygen do I have? 1. Okay, so according to the law of conservation of mass, these numbers have to be the same. They're not. So what we can do is we actually get to put numbers in front of the compounds to show how it balances out. Because you can have more molecules of something. Okay, you can't change the actual molecule, but you can put in more molecules. So what I mean by that is something called, so this shows that atoms are conserved, but you need to have coefficients. These are numbers in front of chemical formulas, and they show how many of each compound is there. So the place to put in a coefficient, I usually draw a little line in front of each compound to show that I can put a number there to represent the coefficient. Now, if there's no number there, we just assume it's 1. Okay, so right now they're all 1. But this stuff down here is not equal. So I can add numbers here to make it. So if I added a number here, what could I get so that the oxygens were the same? I could put a 2 here. So what you do, almost the way you think about it, is this 2 is like you multiply it in to figure out how many of each atom there is. So now it's like 2 multiplied by 1 is now 2. So now I have 2 oxygens. So my oxygen line is good. But now, Carson, go ahead.
So why wouldn't it just be H2O2?
Because H2O2 is hydrogen peroxide. If I put the 2 down there, I've made a totally different compound.
But does it actually have 2 oxygen atoms in the actual chemical?
In this?
Yeah.
No, okay, so it means that I have 2 whole water molecules. So it's like I still have a water molecule, but I have 2 of them. So that's why I couldn't add a 2 here, because if I add a 2 there, I have hydrogen peroxide. I don't want to drink hydrogen peroxide, I need to drink water. So that's why we can't change the actual compound. So now though, can you see what else I changed when I put a 2 there? I made 4 hydrogens, so it multiplies in. 2 times 2 is now 4. I have 4 hydrogen on this side.
So that's not the same.
So now it's not the same.
Can you change the other side?
Now I can change the other side, okay? So now how do I make sure, so my oxygens are still good to go, but my hydrogens, what needs to happen?
So you multiply that by
I need to put a 2 here, so that 2 times 2 is 4. So now this line is all good, and this line is good. Now, what did I say would be the number here? 1, yeah. So you don't have to put in the number 1. We can just leave it blank and assume it's 1, but if you'd like to put in the number 1, that's fine too. Go ahead.
Do we have to put in that little line?
No, but like in your workbooks, the line will be in there for you.
Oh,
Yeah, I think. But if not, you don't have to put in the line. I just like putting in the line to start with that.
oh.
Yeah.
Can you like, on the host H2O,
Yeah.
can you have like 2 oxygens in that or not? Like a big coefficient? Or it has to be like 2 of the whole H2O?
Like this?
No, like, you know how you put the
H2,
2 at the
2O.
front of the H? Like you went like that? No.
He means like H2 and then 2O.
Yeah,
H2.
And then a big 2.
a big 2.
Or can you not put
Like
like
a
a
coefficient
coefficient in the
for all
middle?
of it all.
No, you can't put it in the middle.
Okay. just
You're
one.
only allowed to put it at the front of the whole thing.
Okay.
Yeah. Just in front of the whole thing. Yeah. Okay. I've already put in this. I've already taught you this. But right here, this is called a subscript. These are the letters below to the right of each compound, show what state each it is. So this is a subscript. This is a subscript. This is a subscript. So you need to start writing those in. Now,
So how many atoms of hydrogen in a reactant is 2?
where does this say? So how many atoms? Well, at final, we have 4.
Oh yeah.
Yeah. Okay. So these are the main steps of basically what I just showed you, and I'm going to give you lots of examples. So when writing the correct skeleton equation, check your formulas to ensure they're correct. So you need to make sure, like, you know what water is. You know that H is H2. You know that O is O2. Include all states of matter for each reactant and product. so the ones you had to memorize. And then if it's happening like in solution, you need to look at your solubility charts all the time to look and see if you write aqueous or solid. Then balance the atom or polyatomic ion present in the greatest number first. Find the lowest common multiple to obtain whole number coefficients. And you just keep repeating that. Sometimes you'll change something and it will throw other things off and you kind of have to keep going. So please, please, please never do this in pen because you will be crossing off. You need to be able to erase. You have to. If you give me your assignment in pen, it will be 100% wrong. You have to do it in pencil. I got lots of pencils in this drawer if you're low.
What does it mean by do it in the greatest number first?
Like find well, I'll show you more examples of how to get to it, but like the numbers that are the most, how do you change them? So like when you look at how many atoms there are, pick the ones that are the greatest, that are different. Hence, and I'm going to show you these as we go through more examples. When oxygen is present, balance it last. When single elements are present on one side of the equation, balance those, try and balance them last. As long as complex ions are found intact on both sides, treat them as one group. So like, write PO4 all together. Don't go P and then 4. Because if PO4 is like the polyatomic ion, keep it all together. Or say like NO3, like just keep it all together. And again, I'm going to show you examples. And then at the end, check once again to make sure that the equation is balanced by creating a table of atoms on each side, just like I had shown you. Now, I have those questions as practice problems, but they are actually going to be too hard for you to do today. So what we'll do is we'll just do like a 1-minute stretch break, and then I'm going to actually go into the next lesson, but you don't have to do those, okay? The next lesson I'm going to take you through a little bit of baby steps, okay? So you don't have